Welcome to Chapter 2 for Intermediate Algebra. We are going to be looking at equations, inequalities, and problem solving. As you know, my name is Bo Corkins, and I'm going to guide you through this wonderful material today. So, it all starts with two very simple principles, the addition principle, all right, and the multiplication principle. So, these two principles are basically the concept of do the opposite and do it to both sides. Don't get caught up in the terminology, right? Subtract, multiply. I was like, doesn't really matter. Do the opposite, do it to both sides. So, right here we have a couple examples. Solve the following for the unknown. X plus 7 equals -3. That means subtract 7 from both sides. That cancels out on the left side. And that gets x equals -10 on the right side. Similarly, 56 equals 7t. It does not matter if the variable is on the right or is on the left. We isolate the variable, solve for the variable. So 7 is being multiplied, so I'm going to divide both sides by 7. 56 divided by 7 is 8, equals t, and that is our solution. Do the opposite, do it to both sides. What's way more fun, though, is using lots of principles together. And the first one, all right, that we are going to see is the rainbow. All right, so doing the rainbow, all right, which is bringing that, we need to bring this negative into the parentheses. All right, so it kind of looks like a rainbow when you have lots of them. Right? And you could use different colors, which is why we call it the rainbow. The official property is called the distributive property, but I like to just do the rainbow, and that is part of the polynomial dance. So, rainbow that negative in, that gives us 6b minus 3b minus 8 equals 16. Simplify down, combine like terms. And when we get back here, this is what's known as two-step algebra. I have two steps, basically add or subtract, and then multiply and divide to get the answer. So add 8 to both sides. That goes away on the left side, and that becomes 24 on the right side. And then divide by 3. And that gives us b equals 8. It's also good to plug this back in and check. All right, so 6 times 8, 48, minus 3 times 8 is 24 plus 8. So 48 minus 32. And 48 minus 32 is 16. And oh, look at that. We have 16 equals 16. All right, this is a always true statement. That's how you check your answer. All right, plug it back in to make sure, all right, that the left side equals the right side. Let's look at another one. Fractions are our friends. All right, don't get all messed up with some simple fractions. Take it one step at a time. So notice I see my denominators as 8, 4, and 16, and of course 1. So that means the common denominator among all of these is 16, right? The whole idea is that 1 times 16 makes 16. 2 times 8 makes 16. 4 times 4 makes 16. I can create 16 as the, right, what is called the least common denominator. Now, remember, if you ever get confused creating your fractions, if you multiply all the numbers together, all right, the fractions are 1, 4, 8, and 16. If I just multiply all those together, that will create a common denominator. It is not the least common denominator, but it is, all right, a common denominator. What we're typically looking for is the least common denominator, LCD, right? Remembering our pre-algebra. So once I've identified what the least common denominator is, the best thing is to multiply both sides by that value. So I'm going to multiply both sides by 16 over 1. Now, be aware this is going to get worse before it's going to get better. So once again, I'm going to rainbow. I'm going to bring this piece in, and I'm going to write this out in complete detail. Once I have this, now, when you get better at this, you can skip more steps, but I want to show this very thoroughly the first time. Notice that I just brought that 16 over 1 into every single piece, then one little piece at a time. All right, so one, all right, expression, one piece of the entire equation at a time. I'm going to cancel my values. So 16 and 8, all right? 8 goes into 16 twice. 8 goes into 8 once. 16 goes into 4 4 times. Goes into 1. All right, 4, 1. 1 and 1. And that goes away. Now, here's the best part. Look at all these denominators. All these denominators are now 1. If your denominators are all 1, that means you don't have fractions anymore. That's why I really like this method. It gets a little rough just for one step, and then your fractions disappear. Now watch. All right, so this first piece, 2 times 7x, 14x, minus 4 times 1, plus 4 times 3x, 1 times 1, 16 times x. Notice, all right, no fractions. Then I can just simplify this down. All right, what are we at? 26x minus 4 equals 16x plus 1. Bring the x's to one side and the numbers to the other. Sorry, I was already doing that math because I'm like, oh, 4 plus 1 is 5. That leaves 10x over here. All right, the negative 4 plus 4 goes away. 16x minus 16x goes away. And that leaves 5. And then one last step, divide both sides by 10. X equals 1/2. So notice how quickly this actually simplifies down. All right, let's take a look at some others. Always start with rainbow and start with the deepest nested values. So I'm going to start with this -4. All right, not the 3 all the way in the front. While I'm at it, what I do on the left side, all right, has nothing to do with what I do on the right side. So similarly, I'm gonna rainbow this -4 in as well. Once you rainbow something, and the important part is the parentheses go away. So what I'm gonna be left with here is 3, 2, all right, minus 4x plus 4. Notice that that inside set of parentheses disappeared. On the right side, 3 minus 4x minus 8. Once I rainbowed that -4 through. Before I go rainbowing again, because I see I need to rainbow this 3 all the way on the far left in. Simplify for a step before you rainbow. Same thing. Simplify on the right side here. Now I'm going to rainbow this 3 in because now notice, look, I'm only rainbowing it into 2 pieces, all right, instead of 3. And that avoids mistakes. And then once I'm here, get the x's to one side and the numbers to another. So, all right, that gives me -8x on the left side and -23 on the right side. Divide both sides by -8 and x equals 23/8. It does not matter if the solution is an integer, a fraction, crazy decimal, okay? Just a number. Now, again, you should always check your answer. I'm kind of bad at plugging back in because I'm pretty good at this. I know I'm correct most of the time, but even I make a mistake. You should definitely plug your answer back in. All right, once again, I see fractions. So, or to simplify this, 14, 49, and 7, the common denominator, it is not 49. Oh, it seems like we want to do 49. Okay, 7 times 7 makes 49. Ooh, 2 times 7 makes 14, which means I actually need a number that they both have in common. That would be 98. 2 times 7 times 7. So I'm going to multiply both sides by 98 over 1. I'll write this out the long way again just so we can see it. '98 and 14, that's 1, that leaves a 7 there. '98 and 49, that leaves a 2. '98 and 7, that leaves 14. Okay, so this becomes 7 times x. And notice, once again, all the denominators are 1. 7 times x, 7x. Minus, actually, let's write this out slower. This is 2, 5x plus 2. That whole thing is in the entirety of the numerator, which means there's technically, all right, hidden parentheses around that. Same thing with this one. That's the thing I see people mess up. That 14 has to go into both the 3x and the negative 4. That means we are rainbowing. And then simplify, again, combine like terms before I continue. 7x minus 10x makes negative 3x minus 4 equals 42x minus 56. Get the numbers to one side. And again, we're just so familiar with bringing the x's to the left side, but you can move it either way. So that gives me negative 45x equals negative 52 divided by negative 45 on both sides. (52 45ths). And that does not reduce. Always good to look to see if the fraction does reduce down. All right. And the last problem from above. So solve. All right. Looks like we got a lot going on, even actually a quadratic piece. All right, because that's what that x squared is. But take this one step at a time. I see lots of rainbowing. And notice right here, even though the x is in the back, that still means rainbow that through. I got a rainbow here, and oh man, look at that, rainbowing all over the place. All right, so let's see what we have. X times x is x squared. Negative 4 times x, negative 4x. 3x times x is 3x squared. All right, so rainbow that guy all the way through. All right, and let's simplify the left side and the right side. Well, the left side is pretty easy. X squared minus 4x. Those do not cancel. All right, make sure you understand the concept of like terms, and x squared and 4x are not like terms, which means they cannot combine together. All right. Then notice I have 3x squared and negative 2x squared. Those can combine to be x squared, 3x and negative x. That makes x, and then plus 10. Now, here's the big part. Do what we normally do, right? Get the x's to one side and the numbers to the other. So I'm going to subtract x squared and minus x and line them up on the left side underneath the same terms. Right? Cancels here on the right side. Notice here on the left side, x squared minus x squared, those go away as well. So all I'm left with on the left side is negative 5x equals 10. And I'll look at that. Divide by negative 5. X equals negative 2. So, all right, stuff simplifies down. Don't get caught up if it seems like it's not going well initially. All right, take your time, keep solving it down. All right, one more piece here. So some terminology, a linear equation, all right, that's basically anything ax equals b form. Everything we just solved was a linear equation. We have numbers and stuff with first powers of x's. This last one is the only one that actually wasn't a linear equation because it had x squareds in it. A few terms. An identity is something that is always true. All right. 17 equals 17. That's 16 equals 16 when we checked our answer. And without a doubt, the biggest one is 0 equals 0. That is an identity. That is always true. Contradiction is something that's never true, right? N like n plus 5, n plus 7. What that actually becomes when you get rid of the n's on both sides, it says 5 equals 7. That is never true, right? 5 is never equal to 7. 0 is never equal to 1. Those are contradictions. And lastly, what we solve most of the time is a conditional. Something that is true when you find a particular solution for it. X equals 7. Like we found above here. X equals -2. It has a solution. And then when it has no solutions, we call that the empty set. When it has several solutions, we call it a solution set. Just some terminology. Without a doubt, the biggest ones we want to focus on are identity, contradiction, and conditional. So when we go to solve this, I want to solve these equations and state if it's an identity, contradiction, or a conditional. So start like we always do. Rainbow. So on the left side, 2x plus 7. On the right side, I have 7x plus 7 minus 5x. Combine like terms. 2x plus 7. Notice I can see it right here. The left side is exactly equal to the right side, but you can verify that by subtracting 2x from both sides, subtract 7 from both sides, and notice 0 equals 0. That is an identity. That is always true. Two x plus 17 equals 5. So solve it. Minus 17 from both sides. Divide by 2. X equals -6. When you get it, x equals a number, this is a conditional equation. Right? This is true if x equals -6. It is not true if x equals anything else. If x equals 19, this equation does not solve. All right, then lastly, 3x equals 3x plus 1. Notice subtract 3x from both sides. 0 equals 1. That is never true. That is a contradiction. And basically, that's how you identify them, and you will always identify them in that method. All right. We're going to end it there. Thank you, and that was, have a wonderful day.